In this video, we're going to look at an old vintage AGS Trio. Now, AGS was the predecessor to Kenwood taking over the Trio brand, and this unit has a problem with the FM reception, and one of the knobs got broken by the client. Let's take a look at it. Well, today I have a real old beauty here. This is an old AGS Trio. AGS stood for American General Supply. This was built by the Trio company. Anybody who knows the history of Trio, Trio later became Kenwood. So then it was Trio Kenwood. And of course, today Kenwood is JVC Kenwood. But anyway, a little history. This is an old AM/FM receiver that I received to have a quick look at. This, as we notice, the bass control is broken. And that's how I received it. The client that owns it, the control was bent, and he tried to straighten it and ended up with a broken control. So we're going to try and find a new control for this thing. I'm going to pop it apart. We'll see what the value of this control is. It's probably a 50K dual pot is what I'm thinking that this thing's going to be. But I figured you guys might like to get a look inside one of these old beasts and see what they look like. Now, when's the last time, if ever, do you remember seeing a product with slotted screws on it? And not only slotted screws, but it also has finger grips for once you loosen it, you can spin them out with your fingers. Now, this is something that I don't know what year this is, but I'm going to say it's probably it's a solid state unit, so it's probably going to be late 60s, I would guess. I'll have to look this unit up and we'll see what year this one came from. Pretty dusty. Lots of old caps in this thing. Wow. Let's dust this off first. We'll get the air compressor out here and blow the dust out of this thing. So it looks like it's a 30, is that 309 or 30G? Anyway, it's all solid state, as you can see. It's got your AM/FM dial, tuning meter, speakers on and off, power on and off, volume control split. It's got a AM, mono, FM, automatic stereo, and phono. We're going to connect this thing and see how it sounds. And anybody dare to guess the power output on this thing? Anybody want to gander what the power is? Not very much, is what I'm going to guess. Output transistor should be underneath here. Suspense is killing you, isn't it? 2SD 143. Now, according to my NTE cross-reference, that would cross-reference to an NTE 175. The data sheet for an NTE 175, which is going to be a replacement, so it's going to have probably higher specifications than this. Collector current and base current is 1 amp. It says power dissipation on this device would be 35 watts. But you're not going to get 35 watts out of a receiver like this. This is not a Class B amplifier. This is they call it a complementary output, but basically it's using 2 NPN transistors and it's using capacitor coupling for the speakers. So conservatively, it's probably rated at 20 watts per channel. I would guess. A little history in amplifier design. This is a complementary output. It's called a quasi-complementary output, and it uses 4 NPN transistors, 2 per channel. The reason for this is, in the development of power transistors, NPN transistors were the first transistors to be developed in the power type transistors. You've got 2 different types of bipolar transistors, NPN and PNP. And in the early days of the power transistors, the PNP transistors were available in many types, but they were all low voltage signal type transistors that were used in circuits like the driver circuits and so forth. But when it came to the power transistors, PNP was behind the NPN in its development phase, and even when PNP power transistors did become available, they were much more expensive than their NPN counterparts. So most amplifier designers of the day went with this quasi-complementary output, which used 2 NPN transistors operating together, and they use a capacitor to remove the DC component that would be present at the midway point feeding the speakers. This was a way of achieving the higher power with a single-ended type output from 2 NPN transistors. Once the price dropped of the PNP output, then they moved to produce Class B amplifiers, which used an NPN transistor and a PNP transistor, one to produce the positive portion of the waveform and the other produced the negative, and they would hand off at the switching point. And that created its own can of worms called switching distortion, which was soon overcome by the Class AB design. The Class AB design, what they did was they introduced a small amount of bias to the base of the output transistors to keep the transistor that wasn't conducting from going into full cutoff. So basically how it works is you keep a small amount of current trickling through your emitter to collector junction at all times, whether there's any signal passing through it or not. And then as the waveform increases to the positive swing, the transistor that's amplifying the positive will go into more conduction, while the transistor that's amplifying the negative will stay at its idle. As the waveform reverses phase and it crosses the zero baseline and goes into negative, the positive transistor is now at its idle current and the negative transistor is going into its conductive phase. That's a Class AB design, and that was commonly called a push-pull. That was used in vacuum tubes as well. Anyway, we can tell by the size of this transformer that this thing's not going to have a whole heck of a lot of power. I'm going to guess 20 watts per channel, but it could be less than that. It might be 15, but I doubt that it's going to be more than 20 watts. But I figure we'll hook the speakers up on this thing, and we're going to take a listen to it. Now, before I do, I want to make darn sure that my speakers are both referenced to ground and we don't have floating negatives, because my test bench speakers are grounded. The two negative terminals are grounded together. So I'm just going to get my meter and measure the negative terminals just to make sure that they are in fact connected, and then I can hook it up to my bench speakers. Otherwise I have to find some separate speakers. So negative terminal, negative terminal. Yes, okay, good. You see, we're grounded here, and we're grounded to the chassis as well. So the negative terminal is indeed grounded, which is what I fully expected. So let me connect this up to my bench speakers, and we'll take a listen to this thing, see how it sounds, and then we'll get the bottom off it and take a look at the control that's broken, and then I'll have to try and find a replacement control. Volume, minimum, power. Speakers are on. That's interesting. When the button's pressed in, speakers are off. That speaker's on. Let's just see. It's on AM, so let's see. Oh, controls are dirty.
Visit meridianmeats.ca. Hi, I'm Josh Penner of Meridian Meats and Meridian Farm Market. Fire up
We have lots of noise. We have lots of noise that blocks out most AM signals around here.
3 for just $9.
Lots of digital noise from digital devices running here at my place.
Tumaki. Head to Domino's right now because this deal ends.
Let's take a listen to FM. Put it in stereo. Appears to work. No antenna on it either, so I'm taking it down to my modulator here. I think that's my modulator.
Over the campground table, and it's, you know, I've asked people.
Yeah, that'll be it. Looks like the stereo light might be burnt out. Tape source switch is kind of that needs clean. Let's get the bottom off it and get the controls cleaned. See if that improves the operation, and then we'll deal with this bass control. So here's the broken control on here on the bass control. You can see all the capacitors strapped around it. It's a 50K dual control. This is the treble control. I'm just going to give them a shot of cleaner first, and we'll see how they clean up. So first we'll get the volume controls over here. Yeah, that control's sounding good now. Function switch. I'll do all the rest of the switches while I'm at it. That tape monitor switch doesn't appear to be in great shape. Gonna put an antenna on the FM input. That'll work a little better with an antenna. Needs a light bulb. Easy enough to change. what voltage this thing is here. Let's see if I can find out the voltage. Probably a 12 volt bulb, I'm guessing. 8 volts. Oh, maybe not blown. It doesn't look like the filament is burned out on it. Let's just check this thing with a meter and see. Maybe we have a circuitry problem and that's why the light's not turning on. So let's just see if this bulb is burned out or not. Nope, this bulb is good. So we have a circuitry problem. We have to figure out why this isn't turning on the MPX light. I actually have something to do on this. Either that or it just wasn't making a connection. Let's just put the light back in, screw it all the way in and see if it lights up. Nope. Okay. Now I gotta figure out why the stereo light's not working. Okay, I'm not getting any stereo on this receiver. I'm just clipped on and I'm monitoring the output from the detector here. This is one of the buffer transistors right off the FM discriminator, and if we look over at Mr. Digital Scope over here, we will see that I indeed am seeing the 19 kilohertz pilot. If I hit the, I think it's the choir? Nope, sorry, wrong button. Measure. 19 kilohertz. If I go to mono mode, you'll see that that goes away because there's nothing there. So this is our carrier, so we know that the FM pilot tone is being received. Turn it back to stereo. There's our 19 kilohertz signal back. Now we just got to figure out why it's not turning on the stereo decoder circuit and decoding it. So the fact that I've got my 19 kilohertz signal with my sidebands on it in the stereo circuit and it's not demodulating, I've got to think it's one of these, probably one of these little caps in here. One of these little coupling caps has gone open because this thing's old, right? Very old. Of course, I look on the internet to see if I can find a service manual for it, but no such luck. I see a couple of them being sold for like 45 bucks on eBay, but that's not going to happen. So I guess we'll check some of these caps in this. I'm pretty sure this is our decoding circuit here. So I'm just going to flip this thing on its side and see if we can scope it a bit more. Kind of work blind here. Okay, here's my outputs here. 19 kilohertz on. Put a mono, gone. Something right in this area here, I think. Turn a 19 kilohertz back, more in stereo. Something right in this circuit here is not switching. Okay, this transistor down here, which looks to be the one that switches the light actually on and off. Base emitter, looks like this is it here, emitter collector. Where's the base over here? Okay, continuing on with the AGS. The AGS Trio. It is a Trio AGS. AGS Trio. I've got a new control here. This is going to replace this broken base control. So what we're going to do is I'm going to take out the control, first of all, and we're going to transfer the wires over one at a time. We'll get the base control dealt with and then get back into working on the problem with the FM stereo circuit on this unit, because as we found out, there's a problem with the stereo circuit as well. So basically I just have to transfer these capacitors and resistors from the old control to the new one. And we're just going to do them one at a time, one terminal at a time. Easiest way to do this is probably to cut the old components off one leg at a time, and then we can transfer the wires over. That's the center one. So that's one channel. and then we'll do the same for the other channel. You see what I'm getting at, right? We'll just solder them down complete onto the new control. I know someone's probably going to say this is not the right way to do it, and I should unsolder the components completely. I don't want to put any undue stress on the leads from these ceramic capacitors, so I'm trying to switch this over in the least stressful way, which is just to cut, and we'll bend over the tabs, crimp them down, and solder them in place. That's probably the least amount of stress to the other components that are tacked on here. So I'm just going to bend my leads over at 90 degrees. And we'll put some tin on them. This is a very old control. I don't know how old this replacement is, but it looks like it's been sitting around forever. So we're going to tin the leads. And then it's just a matter of getting the control in place and reattaching. The leads here. Okay, that's 5 out of 6 connected. One last one here to do. We can mount the control back in place and then get back into troubleshooting the FM circuit. Mount the control back in there. See how it fits in there perfect. It's exact size. Oh, maybe not. Maybe not. It's a little bit shorter, so I might not be able to put this washer on. The shaft length here is slightly shorter than the other one. But I don't know if I'll be able to get the nut or the washer on there. The nut will go on for sure, but I might be able to get that washer in there. Let's see. Let's see whether it will go on. Oh man, I probably won't be able to put this washer on just because the shaft is just slightly, the threaded portion of the shaft is just slightly shorter than the other one. But you know what? It will screw on. so it will work. It's just not. The threaded portion on this one was slightly longer than the replacement. And even though the replacement it's fully in place and it's centered and the alignment pin and everything's there, and I can tighten up the nut, I can't put that washer on behind it. Which really shouldn't be a big deal. As I dump all the screws, control to minimum. Looks like it works. Okay, so little less tension, so we'll just spread those out a bit. There we go. Beautiful. Looks like $1 million. There, that's better. That's a bit better. It's got the alignment a little better now, I think. Yep. Okay, that part's taken care of. We'll hook up some speakers and now we can start troubleshooting the problem with the stereo decoder. I've created a dual tone FM transmitter. I use my little MP3 transmitter, and I've created a dual tone for it with I think it's a 400 hertz tone on one and a 600 hertz tone on the other, if I'm not mistaken. So we have dual tone. So what we should have here is we should have the 400 hertz tone in the left channel and the 600 hertz tone in the right channel. And of course, if I go to mono, we hear both. Right? That's what we should have. Left channel, right channel. On this unit, we only hear the mono channel regardless whether we're in stereo or mono mode. So we have a problem with the FM stereo decoder. That's going to do it for part one. In part two, we'll look at the multiplex decoder. Thanks for watching.